Hi, I'm going to be going over my package Basal and Bark just to kind of introduce some of the functionalities in this video. So I'm starting off here at my GitHub repository page. Just recently, a couple minutes ago, 13 minutes ago, says bumped from version 0.0.6 to bump that to 7. Improvements from 5 to 6 are some of the main ones I'll be covering today. 6 to 7 was just a couple of updates to documentation, trying to make it easier to understand for newcomers to the package to get an idea of what's going on with the package and being able to follow along with all the information that I'm trying to share with everyone that is interested. So I'm going to go ahead and go to my documentation website here. And I'd like to start by kind of going over some of the new functions that I've added. So, and before I do that, I'd like to mention the whole point of the purpose of this package and the goal of it moving forward. The reason it's even titled the way that it is, Basal and Bark. It is intended to be a package for new and improved ways of analyzing forestry data. So ways that you can compare data sets to each other, and specifically in forestry, and even more so being able to place all of that information into a geographical framework, some sort of a GIS perspective to try to solve some of the pertinent forestry issues of today. So I guess moving on into the real functionality, some of the different building blocks that I've placed into this package, functions that can be used together or separately to hopefully kind of help to analyze some of the forestry data sets and maybe get some new insights and make it easier for for programmers like perhaps someone viewing this video to be able to develop some sort of a mapping framework that users can easily engage with to consider different troubles and concepts with forestry. So I'm going to go through and mention the main functions that I've added to my package thus far that contribute to the analysis of forestry data. First and foremost, I'd like to start off with this add GEE data. This is adding my first data set from Google Earth Engine. This is the Hansen et al. Forest chains data set. And so the way that this function works is it takes in really one parameter. The self parameter is the map object of my Basal and Bark package. So there's a map class to the Basal and Bark package. And so it would be your map object dot add GE data, and then your actual parameter that you would pass would be the state parameter, which is the STUSPS attribute field. It's the two-letter abbreviation of the state, and you'll see throughout that is a pretty common parameter that's passed to most of these functions. Okay, so there's an add Google Earth Engine functionality there. There's an add reference data. Currently, this is just adding state data, so state boundary data to the map, and you'll see where this can kind of be a useful functionality, very, very similar to the add shape method in this package as well. The main difference is that it doesn't return back a new leaflet map. It's kind of a silent function, but very, very similar to the add shape method as well. And as I'm going through these, I'd like to make a note of the fact that I have a lot of different functions that I'm not mentioning that add functionality to the entire package, adding rasters, interactive base maps such as that. Useful and helpful, but not necessarily what I want to highlight today, and just trying to look at specifically how can we maybe better analyze forestry data sets with some of the new tools that I've been developing. Okay, so moving on along, After the add ref data, the next one that I've added is this EE tile layer. I'd like to thank Dr. Q Sang Woo on this one. He's the developer of this function. I learned from him this function. This is from his GEO demo repository. And so what this does is this EE tile layer converts an Earth Engine layer to an iPy leaflet tile layer. And so I'd like to, I guess, make a mention of it now. The Basal and Bark module. So I have two modules here, Basal and Bark and Folium. Just the base Basal and Bark module runs on an iPy leaflet map base. And so therefore everything needs to be converted to an iPy leaflet format to be able to be added to the Basal and Bark map object. And so this function is extremely important for this add GE data function that I started off talking about, because without this conversion from Earth Engine layers to iPy leaflet tile layers, it would be much more complicated, and I'm not sure I would be at that point where I could have this function in here. So that's a very important one. Moving on to this find int. This is short for find the intersection. And so I think that it'll become more clear when I go to, next I'm going to go to my Google Collaboratory to kind of better showcase kind of the way that you can combine these different tools together. So this find intersection tool will take in so the self parameter is your map object, your Basal and Bark map object, and then the states, that's going to be all of your geodata frame of your states, and finally your GDF, that is going to be a geodata frame of point. And so the idea is that the function is going to return the state in which the GDF point intersects. So I think that it may seem a little trivial right now, but it can be used in a very powerful way, as I think will become very apparent going to the Google Collaboratory. Okay, moving on to the next one. This is very kind of complementary to the add GE data. This is the get API data function. It accepts two parameters, the state, which that's going to be in the form of a string. That's going to be four numbers though, but in string format, and so that's the year, and then the state is going to be a 2-letter abbreviation, as was mentioned before. That's going to be the STUSPS abbreviation. This get API data goes out to the FIA, which is a part of the U.S. Forest Service. FIA stands for Forest Inventory and Analysis, and they have their own API that you can use to get different estimates, forestry estimates. So I'm able to pull in data from two different data sources here, from Google Earth Engine and also this FIA API. And you'll see in a minute here how that's kind of a neat thing to be able to compare the two together. Moving forward to the next one is this make points from click. So really the main, aside from self, the main parameter that is being accepted here is this coords parameter. It's the coordinates or the location. If you were using this in a different context than what I've used it for, you can just pass in a set of coordinates that you yourself have chosen. That's really all that it's taking in. I'm using it specifically for making points from after I extract the coordinates from a click location on a map, then I'm making a point on a map where they have clicked. That is not really, that action is not required though, even though it's in the name. You could just add coordinates to it, run the function, and it would add a point to your map just from the coordinates that you added in as parameters. Okay, so the main point of this function is that you're adding in a point to your map, so it becomes a little more interactive when you can start to kind of create your own, almost kind of create your own layers in a sense. And finally, this states dict is short for states dictionary. Using the FIA Forest Service data set, they have their own keys for each state. And so when you are trying to extract the estimates that are present in their API, you have to be able to provide their state key. And I did that via this creation of a state dictionary. Um, and basically it acts basically as a class variable, where every time that you start a new Basal and Bark map object, you end up with a new states dictionary, just so it's always present. You can always use it. Okay, I'm going to go ahead and move on to the Google Collaboratory, and like to show off some of the functionality, what happens when what you can do when you really kind of put all these pieces together. So first and foremost, I ran the first 3 blocks of code here prior to starting this video. So the pip install Basal and Bark, the package that we're talking about. And then mainly I installed widgets and widget control. You'll see here I kept the front end. All the widget control is on the notebooks. All of the back end was left to my package. That was an organization decision. I think that it makes good sense to me to do it that way. There are many different ways to do it, though. That is what I chose to do, though. So I kept all the widget control on the front end here with the Google Colab. And when we're talking about using things like the Google Earth Engine data sets, it's not just, you can't just go out and pull it in. You have to have an account with Google Earth Engine. And so that's what this next block of code, this import EE and the authenticate function does. So if you don't have an account with them, you need to get one if you want to use the data. If you don't want to use the data, no problem with that. My package is still very much functional without it. It definitely adds to it, and it's much cooler though. So I recommend getting a Google Earth Engine account if you don't already have one. That way you can fully tap into not only what my package can do, but start tapping into all the power that's present for data analysis in Google Earth Engine itself. Okay, so prior to starting the video, I went on ahead and authenticated for this session, and it'll tell you how to kind of go about that. Once you run that block, it'll give you instructions and it'll tell you what to do. Okay, so let's kind of dive into what I've really got going with my package itself. So first thing I'm going to do is I'm going to create my Basal and Bark map object. And Basal and Bark, I imported Basal and Bark just as Basal, so that's why it's just Basal here. So just kind of keep it shorter. And I'm going to create kind of a basic environment. So I'm going to add a layer control, and I'm going to go ahead and show the map. Very simple map, just because I have a lot of functionality with it available, but that's not necessarily what I'm trying to show off right here. So you can see that I've got this layer control here, what I just added in this block 6. So next thing I'm going to do is add my reference data, so loading in the states. And so what this is doing is it's just pulling in, it's not plotting it on the map, but it is present. I could plot it on the map. I chose not to. It keeps it cleaner this way. I think you'll see that it can get pretty busy on the map. So I load it in so that it's for its own like kind of back-end reference, but the user doesn't really need to see it. And here for the next block that I'm going to run, it's going to go ahead and create an output widget. And the main thing that's going on here is putting in a drop-down widget, and it's got options for years of inventory, and this is specifically for getting data from the FIA database for the U.S. Forest Service. There are many other year options. These are kind of some of the more present for every state, so you're guaranteed to get a result for every state from these options. So I kind of kept it simpler with that too, just because it's a little bit cleaner. So you can see now I placed this widget in the bottom right. The widget is now present in the bottom right of the map, and we have our drop down with all of our options of our years. So finally, the thing though is that that dropdown doesn't have any functionality yet. So finally, let's add some functionality. This last function, this handle click function and everything included in it is what kind of gives it the real um, interactive touch. So real quickly, I want to run through the layout of this function. Um, and this could be put on the back end. I could be just calling a function just handle click, but I feel like there's a lot more control to the user if I leave this out here. So I decided to do that so that those that are intending to use my package can really make it a lot more personalized, because you've got a lot more pieces that you can work with. So every time you can see, so this is a function, and at the very outside of this block, after the whole function is run, then it tells the map object, the leaflet map, that whenever there's an interaction with the map, to run the function handle click. And so every time that there's something that happens on the map, or something like the mouse goes over it, it's going to call this function and it's going to check and see. So what it's checking here, if KW args, basically is a click. So if the user actually is clicking on the map, first thing you want to do is clear the output of the output widget. Next thing that you want to do is, if it's a click, you want to get the coordinates of the click, and then I tell it to add a point to the map and also return it as a geodata frame. So you're adding a point. So two things are happening on this line of code right here. You're adding a point to the map where they clicked. You're also saving that location as a point in a geodata frame format. And we're going to use that further in the next line here. So now we're moving down here to the find int. We're finding the intersection between our states. That's the reference data that I loaded up here. And so what we're trying to do is we're trying to find which state did the user actually just click in. And so we're going to save that state in this state variable. And finally, we're going to print out a lot of information in our output widget. And then we're going to use this information that we've collected from the drop-down menu and from the state that the user clicked in to retrieve the API data from the FIA database using this get API data function. We're going to return that table, and then we're going to have some summary information underneath it. And additionally, we're also going to use the state information for the state in which the user clicked into to use this add GUI data function. And what we're going to do there is we're going to be clipping the Hansen et al. Dataset to that state that they selected. We're going to plot the data onto the map, the cropped data onto the map, so the user can see the data, as well as we're also going to return a table of summary statistics. So now that I've run everything, I'm going to go ahead and I'd like to demonstrate kind of what this looks like on an interactive kind of map and what it feels like to use it, I guess. So I'm going to go ahead and click on a state. Let's click on North Carolina. And you'll see first thing that it's placing a point on the map where I clicked. And in the widget, you can see also it outputs the abbreviation of the state that I selected. You selected North Carolina. You can see that it has now output underneath the map this table of estimates. This top table is going to be the FIA estimates, and these are estimates for the area of each of these different categories. So there are 7 different estimates here, and that corresponds to the 7 different categories down here. Additionally, this second table is using the GUI map dataset, which is the Hansen et al. Dataset. And so for the cropped data, the dataset that's cropped to the state that we selected, which is in North Carolina, it's giving the summary statistics for that state. And you can see here also that as I've clicked it and it kind of crunched the numbers, it now has mapped that cropped data set onto the map. So if I zoom in here, you can also see that the values throughout space on this data set are being plotted as different colors. So the user can also kind of zoom in and get a visual idea of it, as well as looking at these tables and getting estimates from different sources, from different methods, representing different so the Hansen et al. is a data set for canopy cover. So you just kind of interpreting the values. Maximum value is 100%. That's anticipated and expected. Minimum value is 0. That is also expected. Mean value is a 5.25. Standard deviation is a 4.5, which I'm not sure that has a ton of information just by itself, but I think that this is a good case study to look further at potential uses for it and things like comparing between states. So I'm going to go ahead and select another state just to see, give a base point of, so now that we've got North Carolina to compare to, basically we can compare states and also just start to see things on a map as it kind of dynamically adjusts to what we do. So I just selected another point in Alabama, and we can see that it has registered that we selected in Alabama. You can see that before I even can finish kind of talking through it, the Hansen et al. Data set has been plotted for Alabama. The values here are visibly different, representing the different values throughout for the tree canopy cover. And you can see here that now we've got two sets of tables, and values are different, as well, I would hope that they were different, and they are. And so now we have something that we can compare, and we can keep on doing this over and over again. I can select the same states, and it'll give me the same results. I can select a different year with the same state. It will give me the result for that year in that state. It will change over time. I'll go ahead and select one more just for good measure. Go ahead and do Mississippi. So we've got a point here, registered Mississippi. Should be sitting, yep, there's the Hansen et al. Data set. And now we've got 3 sets of tables. So, and looks like it's still crunching on the last estimate. There it is. GMAP data. So now I've got 3 sets of estimates here that are present. And so it's just, it's very interactive, lots of data to be able to explore, and pretty neat stuff, I think. Right now, this functionality is specifically for the states in the Southern Research Station of the U.S. Forest Service, so it's not the entire United States, but that is functionality coming in the future. So this is specifically for the kind of the southern research station region. Anyway, I think that is all the functionality that I'd like to show here today. There is more functionality to my package, but I think this does a pretty good job of explaining the overall functionalities of my package as far as of the Basal and Bark package, as it can contribute to kind of new ways of analyzing forestry data. Thanks for watching.